project budget is tight and I have to do some value engineering, this is the first place that I look. It requires a real conversation with the owner, but if done right, can reduce a lot of cost with minimal design changes. I'm talking about outdoor and indoor temperature set points. The reason this is a good place to start is because owners don't fully understand the assumptions we make when sizing an HVAC system. So this is going to allow them to make an informed decision on comfort versus cost. So let's start with outdoor design temperatures. When we design for a summer design percent of 0.4, what does that mean? It means that we're making an assumption about the peak outdoor air temperature, in this case 104 degrees, with the understanding that for 0.4% of the year, it's actually going to exceed that temperature. Let's break it down. There's 8760 hours in a year with a 0.4% design. That comes out to 35 hours during which the temperature will exceed our design. In terms of days, that's 1.5 days. Breaking it down further, that's 7.3 days for 2% and 36.5 for 10%. Now, this doesn't mean that for 175 hours, it's going to be 100 degrees in the space. It just means that for 175 hours, the AC system won't be able to keep up with maintaining the indoor set point that you've assumed. So instead of 72 degrees in the space, it might creep up to 75, 76 for that time. Maybe 10% is too much, but with this information, at least the owner will be able to understand the trade-offs here. Speaking of which, let's see how this affects the system sizing. Here at 0.4%, my total load for this project is 160 tons. If I change this to 2%, that drops to 143 tons. If I go extreme and drop this to 10%, then it comes out to 134 tons. Let's jot this down. At 2%, we shave off 17 tons of cooling, which is a 10% reduction. So I'm going to set this at 2%, and then we're going to get into the indoor design set points. This is the other side of the equation. We just talked about options for our outdoor set point. Now we're going to look at indoor set point. In the same way that reducing our assumption about outdoor temperature reduces load, so does increasing our set point for indoor temperature. So a question you can ask the owner is, in peak operation, would you be okay if the indoor set point was 75 degrees Fahrenheit? Let's look at the impact there. Most of these are 72 degrees and our tonnage is 143. Let's up these to 75. It's reduced the tonnage to 136. So changing outdoor design from 0.4 to 2% reduces us to 143 tons, and changing our indoor set point from 72 to 75 reduces it further to 136 tons. That's a reduction of 24 tons or 15%. So you can say, hey, I know we're tight on budget. With a little less comfort control, we can reduce the size of the system by 15% just like that. That may be enough to go down a nominal size on your equipment, but the savings don't stop there. Let me show you something else. I've designed this system in HVAKR, so all of my duct sizes here are linked to my loads and my airflows, and I can look at my schedule prior to changes, and I can look at my duct takeoff prior to any of these changes to see what the original cost is. Take a look at this main right here, 34 by 24 inches. Now I can go make these design changes. Then I can resize my ductwork and it automatically updates. Downsize my ductwork. I can go back to that duct schedule and now get a new takeoff with all the updated sizing. Very quickly determine a real material savings based on those changes just like that. This has made me a superhero when it comes to consulting and value engineering. I can turn around answers so fast.